Hi everyone, I'm Arundhati, and today we will dive into microservices. We will start by defining what microservices are, how they work, their challenges and benefits. We'll look at microservices in action through a case study. Finally, we will discuss whether microservices are the right fit for your projects. Let's begin. So, what are microservices? Microservices architecture is a modern approach to software design that structures applications as a collection of loosely coupled services. Each microservice is organized around specific business capabilities, allowing teams to focus on distinct areas of functionality without being bogged down by dependencies on other parts of the application. These services communicate over a network using lightweight communication protocols, often through well-defined APIs. This independence means that each service can be developed, deployed, and scaled on its own, enhancing flexibility and reducing the risk of failure across the entire application. Let's look at how microservices work. In the microservices architecture, applications are decomposed into self-contained services, each focused on a specific function. This simplifies development and maintenance. Each microservice addresses a particular business feature, like user authentication or card checkout, allowing for specialized development. Services communicate via APIs, ensuring standardized information exchange. This flexibility enables teams to use different technologies for each service, selecting the best tools for their needs. Moreover, microservices can be updated independently, which reduces the risks during changes and enhances system resilience. They also can be scaled individually, optimizing resource utilization and performance. This modular nature of microservices simplifies maintenance and troubleshooting, making it easier to manage complex systems. Let's explore key benefits of adopting a microservices architecture. Microservices enable parallel development. Multiple teams can work on different services simultaneously, significantly speeding up the development process. We see improved fault isolation. If an issue arises in one service, it doesn't bring down the entire system. This compartmentalization enhances overall reliability and resilience. Microservices offer targeted scalability. Each service can be scaled independently based on specific requirements, allowing for more efficient resource allocation. This architecture provides dynamic adaptability. The system can quickly adjust to fluctuating workloads, ensuring optimal performance under varying conditions. Microservices allow for technological diversity. Teams have the flexibility to select the most appropriate tech stack for each individual service rather than being constrained to a one size fits all approach. This model promotes agile team structures. Small and cross functional teams can work independently on specific services, fostering innovation and rapid iteration. While microservices offers numerous benefits, they also come with their own set of challenges. Let's examine some hurdles organizations may face when implementing this architecture. Managing service communication is a significant challenge. As the number of services grows, the complexity of inter-service communication increases exponentially. This can lead to network latency issues and difficulties in maintaining data consistency across services. Decomposing an application into microservices adds layer of complexity to development, testing, and deployment. Each service requires its own development pipeline, testing strategy, and deployment mechanism, which can be overwhelming for teams transitioning from monolithic architectures. The reliance on network communication in microservices architectures can result in higher latency compared to monolithic systems. This increased network traffic not only affects performance, but it also complicates error handling and debugging processes. Maintaining data consistency across multiple services is a challenge. Traditional data management techniques often fall short in this distributed environment. Implementing distributed transactions becomes significantly more complex, requiring careful design and coordination between services. It's also worth noting that microservices can introduce operational complexity. Managing multiple independent services requires sophisticated tooling and expertise for effective monitoring, logging, and troubleshooting. Understanding the trade offs between the advantages and challenges of microservices is essential for using them effectively. Let's now look at how Uber implements microservices. Uber, an early adopter of microservices, faced significant challenges as it scaled from hundreds to thousands of engineers and over 2,000 critical microservices. The complexity of managing interdependencies among services hindered productivity, making even simple feature implementations cumbersome. To address these challenges, Uber implemented DOMA, or Domain Oriented Microservices Architecture. This approach organizes microservices into distinct domains based on business capabilities, such as ride sharing and payment processing. Each domain operates semi independently, allowing teams to work autonomously while maintaining effective communication through well defined APIs. Let's look at some features of the DOMA approach. First, we have domains that are a collection of related microservices focused on the specific business functions. Next, we have layered design, which organizes domains into layers that define dependency management. We have gateways that serve as single point of entry for each domain, simplifying interactions. And lastly, we have extensions. They allow functionality to be added without altering existing services. By adopting DOMA, Uber reduced feature onboarding time by 25 to 50% and categorized its microservices into 70 manageable domains. This structured approach not only improved scalability and flexibility, but also enhanced team autonomy, setting a new standard in software architecture. Let's take a moment to reflect on the crucial question: how can adopting microservices architecture impact your current development processes? I urge you to consider both the potential benefits and challenges this shift might bring to your organization. Think about how your current workflow and team structure would change. How would they need to evolve? Consider what changes in tools and practices might be necessary. Would you need new deployment strategies or maybe different monitoring solutions? Envision the transition process. What steps would be involved? What might your development environment look like after the transition? Take the next minute to ponder this question. Jot down your thoughts or discuss briefly with a colleague if you're in a group setting. This reflection will help you contextualize the concepts we've discussed and consider their practical application in your work environment. In conclusion, adopting a microservices architecture can significantly transform your development processes, enhancing flexibility, scalability, and collaboration. By reflecting on how these changes could impact your organization, you can better prepare for a successful transition that meets your unique needs and changes. Thank you for listening.